Hello everyone, this is Chinnaiah Kalpana here. In this video, we're going to see a problem using the method of undetermined coefficients. So let's get going. Problem: solve y double dash plus 2y dash plus 4y equal to 13 cos of 4x minus 2. So here we are given a differential equation in terms of y, and we are going to write this in operator form. Okay, we are given a differential equation y double dash plus 2y dash plus 4y equal to 13 cos of 4x minus 2, right? We can write this as d square y by dx square plus 2 into dy by dx plus 4y equal to 13 cos of 4x minus 2, or we can write d square y by dx square as capital D square y, where d is a differential operator, plus 2 into, we can write dy by dx as capital dy plus 4y equal to 13 cos of 4x minus 2. Now take y common from all the three terms of LHS. You'll get d square plus 2d plus 4 into y equal to 13 cos of 4x minus 2, right? Which is an operator form, say f of d into y equal to some function of x. Now we can write the given differential equation as d square plus 2d plus 4 into y equal to 13 cos of 4x minus 2, right? Now coming to the problem. Given y double dash plus 2y dash plus 4y equal to 13 cos of 4x minus 2, or d square plus 2d plus 4 into y equal to 13 cos of 4x minus 2. Consider the given equation as equation number 1, and this is an operator form, which is of the form f of d into y equal to some function of x, where f of d equal to d square plus 2d plus 4 and q of x equal to 13 cos of 4x minus 2. Right, now we need to find the general solution to the given equation, which is given by y equal to yc plus yp, where yc is a complementary function, yp is a particular integral. We'll find yc using the auxiliary equation, and later we'll go for yp. We'll find yp using direct formula or with the help of trial method. Now coming to the auxiliary equation. The auxiliary equation is f of m equal to 0, where f of m equal to, we have f of d square plus 2d plus 4, right? Let's replace the differential operator d by m, so that we'll get f of m equal to m square plus 2m plus 4. Then the auxiliary equation becomes m square plus 2m plus 4 equal to 0. Now we need to find roots to this equation, so let's use quadratic formula, minus b plus r minus square root of b square minus 4ac by 2a. This gives us, just compare the equation with am square plus bm plus c equal to 0. You'll get a equal to 1, b equal to 2 and c equal to 4, right? Now substitute these values in the formula. You'll get minus 2 plus r minus square root of b square, that is my 2 square minus 4, 2 square minus 4 into a into c by 2a, that is 2 into 1, which gives us minus 2 plus r minus square root of 2 square is 4 minus 4 4s are 16 by 2, which gives us minus 2 plus r minus square root of 4 minus 16 is minus 12 by 2. Now we can write square root of minus 12 as minus 1 into 4 into 3, right? See, 4 3s are 12. 4 3s are 12. 12 into minus 1 gives minus 12. Okay. Now we can write this as, just split it. Okay. Since square root of minus 1 is I, you'll get minus 2 plus or minus I into square root of 4 is 2 root 3 by 2. Now take 2 common from the numerator, you'll get 2 times minus 1 plus or minus I root 3 by 2, where 2 gets cancelled, and you'll get minus 1 plus or minus I root 3, a pair of complex conjugate roots to this equation. Therefore, m equal to minus 1 plus or minus I into root 3 is a pair of complex conjugate roots. Right? Fine. We know that when m equal to a plus or minus ib, then yc looks like e power ax into one constant into cos bx plus another constant into sin bx, right? Let's write our complementary function using this formula. Y is equal to e power, just compare plus or minus, minus 1 plus or minus I root 3 with a plus or minus ib, you'll have a equal to minus 1 and b equal to root 3, you'll get y is equal to a, that is minus 1 into x into c1, one constant into cos root 3 into x plus another constant, say c2 into sin root 3 into x, which gives us y is equal to e power minus x into c1 cos x root 3, or just write root 3x itself, okay? Root 3x plus c2 sin root 3x. Therefore, y is equal to e power minus x into c1 cos root 3x plus c2 sin root 3x. We got yc. Now we need to find yp. We have yc equal to e power minus x into c1 cos root 3x plus c2 sin root 3x, right? Or we can write this as y is equal to c1 e power minus x into cos root 3x plus c2 into e power minus x sin root 3x. Okay, and also we have q of x equal to 13 cos of 4x minus 2. Now compare the terms of q of x with the terms of yc. In yc, just neglect the constants and observe the functions of x occur in yc and q of x. We have e power minus x cos root 3x, e power minus x sin root 3x, and here you're having cos of 4x minus 2. So q of x has no common term with yc. Here you're having cos 4x minus 2, right? And here you're having e power minus x cos root 3x and e power minus x sin root 3x, right? We don't have any common terms. Therefore, q of x has no common term with yc, right? Therefore, yp must contain the linear combination of q of x and all its linearly independent derivatives. Okay, let's now see the direct formula for yp. And q of x is cos of ax plus b or sine of ax plus b, yp will be a cos ax plus b sine ax plus b. Okay, so in our case we have cos 4x minus 2 in q of x, right? So for a equal to 4 or for a equal to 4 and b equal to minus 2, we'll have yp equal to a cos 4x minus 2 plus b sine 4x minus 2. This is the formula for yp such that it satisfies the given equation. Now let's see the trial method with the help of q of x and all its derivatives. We have q of x equal to cos 4x minus 2, just neglect the quotient 13, okay? Find q dash of x, which is equal to, so we know that derivative of cos ax plus b is minus a sine ax plus b, and derivative of sine ax plus b is a cos of ax plus b, right? Fine. Now find the derivative of q of x, which is minus 4, that is quotient of x is 4 sine of 4x minus 2. Again find its derivative. Q double dash of x is minus 4 into this 4 into derivative of sine 4x minus 12 is 4 into cos 4x minus 2, which gives us minus 16 cos 4x minus 2, right? Find the next derivative. Derivative of cos 4x minus 2 is minus 4 into sine 4x minus 2. See, q of x and all its derivatives. If you observe q of x and all its derivatives, we have cos 4x minus 2, sine 4x minus 2, I mean cos 4x minus 2, or sine 4x minus 2, cos 4x minus 2, or sine 4x minus 2. We have cos 4x minus 2 or sine 4x minus 2. There is only cos 4x minus 2 or sine 4x minus 2, and we don't have any other functions other than cos 4x minus 2 and sine of 4x minus 2, right? Now we'll write the function, I mean q of x and all its derivatives in a set form. Okay, so q of x and all its derivatives just involve cos of 4x minus 2 and sine of 4x minus 2, right? See, you can observe we have in q of x we have cos 4x minus 2, in q dash of x we have sine 4x minus 2, and in q double dash of x we have cos of 4x minus 2, and in q triple dash of x we have sine 4x minus 2, either cos 4x minus 2 or sine 4x minus 2, right? So the set involves cos and sine. Okay, without q of x, I mean q of x and all its derivatives in a set form which involves cos 4x minus 2 and sine of 4x minus 2. Okay, now with the help of this set we will write yp. Okay, yp equal to, I'll take the first term, say cos of 4x minus 2 with some quotient, say a, and the next term sine of 4x minus 2 with some quotient, say b, which is the yp formula. See, you got the same thing, right? Or you can write this as a sine of 4x minus 2, or yp can be a sine of, you can take sine term first and cos next. Okay, yp can be a cos of 4x minus 2 plus b sine of 4x minus 2, or a sine of 4x minus 2 plus b cos of 4x minus 2. Finally, we got the formula for yp. Okay. So we got yp such that it satisfies equation 1. We have chosen yp such that it satisfies equation, which is nothing but the given equation satisfies yp. So we can write the given equation in terms of yp, right? You can write the given equation in terms of yp, then you'll get yp double dash plus 2 yp dash plus 4 yp, it's 4, equal to 13 cos of 4x minus 2. So this equation involves yp, yp dash and yp double dash, right? We have only yp, now we need to find yp dash and yp double dash, right? Let yp equal to a cos of 4x minus 2 plus b sine of 4x minus 2. Now find yp dash, we'll get a into derivative of cos of 4x minus 2 is minus 4 sine of 4x minus 2 plus b into derivative of sine of 4x minus 2 is 4 cos of 4x minus 2, which gives us minus 4a sine of 4x minus 2 plus 4b cos of 4x minus 2, right? Now find yp double dash equal to minus 4a into derivative of sine of 4x minus 2 is 4 cos of 4x minus 2 plus 4b into derivative of cos 4x minus 2 is minus 4 sine 4x minus 2, right, which gives us minus 4 for the 16a cos 4x minus 2 plus into minus minus 16b sine of 4x minus 2, right? We got yp double dash, yp dash, and also we have yp. Now substitute all these three in this equation. One becomes, or we can write 1 as in terms of yp double dash plus 2 yp dash plus 4 yp equal to 13 cos of 4x minus 2. Now substitute yp double dash, yp dash and yp in it. We'll have minus 16a cos of 4x minus 2 minus 16b sine of 4x minus 2 plus 2 into yp dash minus 4a sine of 4x minus 2 plus 4b cos of 4x minus 2 plus 4 into yp dash a cos of 4x minus 2 plus b sine of 4x minus 2 equal to RHS part 13 cos of 4x minus 2. Just simplify it, which gives us minus 16a cos of 4x minus 2 minus 16b sine of 4x minus 2 plus into minus minus 2 4s are 8 a sine of 4x minus 2 plus into plus plus 2 4s are 8 b cos of 4x minus 2 plus 4a cos of 4x minus 2 plus 4b sine of 4x minus 2 equal to 13 cos of 4x minus 2. Now write the terms involving a cos of 4x minus 2 minus 16a cos of 4x minus 2 plus 4a cos of 4x minus 2. Now write the terms involving b cos of 4x minus 2. You have only one term, right? Plus 8b cos of 4x minus 2. Now write the terms involving b sine of 4x minus 2. We have minus 16b sine of 4x minus 2 plus 4b sine of 4x minus 2. Now write the term involving the remaining term, minus 8a sine of 4x minus 2 equal to the RHS part, 13 cos of 4x minus 2. This gives us minus 16a cos of 4x minus 2 plus 4a cos of 4x minus 2 is minus 16 plus 4 is minus 12. A cos of 4x minus 2 plus 8b cos of 4x minus 2 minus 16b sine of 4x minus 2 plus 4b sine of 4x minus 2 gives minus 12b sine of 4x minus 2 minus 8a sine of 4x minus 2 equal to RHS part, 13 cos of 4x minus 2. Okay, now take cos 4x minus 2 common from the first two terms. You'll get minus 12a plus 8 into cos of 4x minus 2. Now take sine 4x minus 2 common, sine 4x minus 2 common from the next two terms of LHS. You'll have minus 8a minus 12b into sine of 4x minus 2 equal to RHS part, 13 cos of 4x minus 2. Now equate the quotient of equate the quotients of like terms. Equating the coefficients of like terms. Okay, I'll begin with cos of 4x minus 2. Equate the quotients of cos of 4x minus 2. You'll get minus 12a plus 8 equal to 13. Now equate the quotients of sine of 4x minus 2. So you don't have a term involving sine of 4x minus 2 in RHS. So you'll get minus 8a minus 12b equal to 0. Okay. Or can write this as minus 8a equal to 12b, then a equal to minus 12 by 8 into b. 2 4s are 8, 2 6s are 12, or 2 2s are 2 3s are minus 3 by 2b. Okay. Now substitute a equal to minus 3 by 2 in this a. You'll get, or you can just solve these two equations to find a and b. Here a and b are the undetermined coefficients. Okay, now we are finding the values of a and b here. So with the help of this a, I'm going to find b. It's 8b, I guess. It's 8b, okay, not just 8. It's 8b. Okay. So 6 are 12. Minus into minus plus. 6 3s are 18. Plus 8b equal to 13. You have minus 2 by b, right? A equal to minus 3 by 2 into b. So you'll get b here. Minus into minus plus. 6 is 18. B. It's 18b. 18b plus 8b equal to 13, which gives us, it was a 16. 26b equal to 13, which gives us 1 by 2. Therefore, b equal to 1 by 2. Now substitute the value of b in it. We'll have the value of a is minus 3 by 4 and value of b is 1 by 2. Now substitute the values of a and b in yp. We have yp equal to a cos of 4x minus 2 plus b sine of 4x minus 2, right? Now substitute the values of a and b. We'll get minus 3 by 4 cos of 4x minus 2 plus 1 by 2 sine of 4x minus 2. Or we can write this as minus 3 by 4 cos of 4x minus 2 plus 1 by 2 sine of 4x minus 2, or okay, we got yp and yc. Let's now write the general solution using y equal to yc plus yp. Therefore, the general solution is given by y equal to yc plus yp, right? Then y equal to yc, e power minus x into c1 cos root 3x plus c2 sine root 3x plus yp, 1 by 2 sine of 4x minus 2 minus 3 by 4 cos of 4x minus 2. This completes the problem. Well, we have seen a problem using the method of undetermined coefficients in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.